अस्सलाम वालेकुम वीवर्स आज हमारे साथ हैं कैथ रॉयड साहब सॉइल साइंस में पीएचडी हैं। कनाडा में ये काम कर रहे हैं रिसर्च का। इनकी किताबें भी इन्होंने कुछ लिखी हैं और लैब में काम करते हैं सॉइल साइंसेज में। ज़मीन को कैसे तैयार करना है, कैसे उसकी न्यूट्रिशन बराबर रखनी है और ज़मीन को काश्त के काबिल कैसे बनाना है। आए आज उनसे सीखते हैं कि वो हमें क्या गाइड करते हैं। हेलो,
Hello.
इंट्रोड्यूस योरसेल्फ।
Okay, I'm Keith Reid with Agriculture and Agri-Food Canada in Guelph, Ontario, Canada. I work as a soil scientist, primarily with soil nutrients, phosphorus, and to a lesser extent nitrogen, and have been working in this field for almost 40 years now, which seems like a long time.
You told me you have a PowerPoint presentation.
A bit about myself, I've actually written a book for the gardeners in our part of the world as well, so that's available for people who are interested. So going back to basics, I think about soil productivity as a stool with three legs. So if any of the legs are shorter than the others, you're not going to get top productivity. We need to have the right physical conditions, so that's good soil structure. And along with good soil structure, we get good air-filled and water-filled porosity. You need to have both the large pores that allow drainage and allow air into the soil, and the fine pores that hold water. The second leg is the chemical, soil pH, whether it's acidic or alkaline, and then adequate nutrients, enough nitrogen, phosphorus, potassium, and all the other nutrients. And then the biological leg is just that you have abundant and varied soil life that help with nutrient cycling, and particularly with the nitrogen availability from the soil. And those three legs, they interact, but we need them all. So if you've got a very active biology, that can help release more nutrients from the soil to compensate for low fertility. If you've got really good soil structure, that can allow the roots to fully explore the volume of the soil and access more of the nutrients that are available. The other side of that is if you've got poor soil structure, but you're putting lots of fertilizer on, that can help to compensate for poor soil structure to some extent. But with any of these, there's limits to how far those compensating factors can go or how much they can do. You cannot put enough fertilizer on to compensate for a really, really small root system, because the plant roots just can't take up enough nutrient per unit of root. And the thing is, biology also goes along with good soil structure. You don't get good biology if you don't have good soil structure and good air-filled and water-filled porosity. So you need all three of them, and they can help compensate, but only part way. Just to review, there's 14 essential plant nutrients. We've been focusing or are focusing on the macronutrients, so nitrogen, phosphorus, and potassium. They're generally needed in the largest amount by plants, and most often added as fertilizer. The secondary nutrients are calcium, magnesium, and sulfur. They're called secondary. Some of them are needed in fairly large quantities, but they were often secondary parts of fertilizers we were applying. So we wouldn't apply specifically to add sulfur, but it would be part of the fertilizer anyway. And then the micronutrients, boron, chloride, copper, iron, manganese, molybdenum, nickel, and zinc. They're needed in very small amounts. Most soils would have enough micronutrients. Some soils are short. Some soils we have trouble with them being tied up, especially if the pH is either too acidic or too alkaline. And so you run into deficiencies there. And again, they're all essential. If we are missing one of them, we can't utilize the other nutrients. So again, you need balanced fertility, but you need to know what you're short of before you go and add something more. Nitrogen, it drives vegetative growth. That's what makes the plants green. It's the central part of the chlorophyll molecule, and often, a lack of nitrogen will show up as a lack of chlorophyll, so you lose that dark green color. It's central to protein synthesis, so any of the protein from the plants has nitrogen as a base. And if we're short of nitrogen, you're going to get stunted plants, pale green leaves, but it's going to show up in the older tissue first. So the plant can actually take nitrogen, move it from the older leaves to the growing point, so the new leaves will look healthy, and the old leaves will look pale or yellowish. Legume crops can fix their own nitrogen from the air through symbiosis with the rhizobia bacteria. So it's got nodules on the roots. That's where the plant is providing sugars to the bacteria in the nodules. The nodules are taking the nitrogen that's in the air and not available to plants and converting it into an available form. So that's the trade-off that legumes do to fix their own nitrogen from the air. The grass crops need to absorb their nitrogen from the soil. So either that's organic matter that's breaking down and releasing nitrogen in a mineral form, or fertilizer that we add. And when we talk about grass crops, it's not just the forage grasses. That's rice, maize, any of the cereal grains. Those are all in the grass family. So they all need nitrogen to be added, or nitrogen from the soil. Phosphorus, it's a critical part of the energy transfer within the plant. The ATP, ADP biochemistry, which is really at the organic chemistry level, what transfers energy from one part of the cell to the other. Also, sugar phosphates are the backbone of the DNA and the RNA molecule, so they're key for reproduction in plants. Phosphorus deficiency, we'll read about the symptoms of phosphorus deficiency, and I have found they are not readily obvious. They don't show up very much. You might see some stunting, you might see some purpling of the leaves, but it tends to be pretty subtle. And often you would have to have a phosphorus deficient plant and one with adequate phosphorus side by side before you could see the difference because of a phosphorus deficiency. And the thing with purpling, which is the usual symptom that's identified as phosphorus deficiency, is really a general stress response in the plant. So there's a lot of other causes for purpling in the leaves. So it's not a very reliable indicator. So that's where soil testing is the best way to tell if you have adequate phosphorus in the soil, or if you need to apply phosphorus fertilizer or some other form of supplemental phosphorus. A little bit about potassium. I know you didn't ask me about potassium, but I think it's best we don't forget it. It's there to help. It really helps maintain the moisture balance in the plant. It helps with disease resistance and lodging resistance. Potassium deficiency can look an awful lot like nitrogen deficiency, where you'll get yellowing in the lower leaves, because again, it can move within the plant. But the yellowing, especially in the grass crops, it's going to be on the outside of the leaves. So from the tip of the leaf back down the margins of the leaf would typically be of potassium deficiency. Nitrogen deficiency, it would be yellowing of the leaves, starting at the tip and going down the midrib. So that's the way you would differentiate between the two. If you're short of potassium, the plant can't use the added phosphorus or nitrogen. So you need to look at that as part of a balanced fertility program. And if you're going to get potassium fertilizer, potassium chloride, also known as muriate of potash, is the most common fertilizer. But livestock manure is also a good source of potassium. So back to nitrogen. If you don't want to use nitrogen fertilizer, would like to build up the nitrogen in the soil for the crops that need it, the first step is going to be to use symbiotic nitrogen fixation. So with legumes, And the legumes, that's beans, peas, alfalfa, clover. There's a number of other legume crops as well. Something that's grown for forage will leave much more nitrogen in the soil than the grain legumes. And if you're going to use the grain legumes as a cover crop, you would need to kill them and work them in while they're still green and lush. If you leave them until they mature, the nitrogen they fix goes off the field with the grain, and they really don't leave much behind. But if you kill them early, you can recover that nitrogen in the next crop. The non-symbiotic end fixation, that's free-living bacteria in the soil. They generally don't produce nearly as much nitrogen because we don't have the carbon source coming from the plant. There's some, in the rice paddy soils, there's been some work there to say there's some bacteria there that are reasonably effective, but not so much in the upland soils. Manure is a good source of nitrogen if you've got livestock manure available. Just remember you have to work it into the soil to prevent ammonia loss to the atmosphere. If you got all the trouble of gathering the manure and spreading it on the field, and then you leave it and most of the nitrogen gets lost to the air, you've lost a lot of the benefit. The final one here is something that was used. I know when our prairie provinces were opened up, there was a lot of these chernozemic soils, the deep black grassland soils. And as the organic matter broke down, it released a lot of nitrogen, and they didn't have to apply fertilizer. They could use that nitrogen in the soil. Now, that breakdown does release N, and the crops can use it, but it also results in a loss of organic matter. And I know those prairie soils, they were able to farm for a number of decades without adding fertilizer. Now they have to add fertilizer, and now they're dealing with issues of poor soil structure or other negative consequences from having burnt out the organic matter in the soil just to get the nitrogen out. So it's something that it's a short-term thing to do if you've got lots of organic matter in the soil, but it's not sustainable in the long run. But phosphorus, you've got for non-fertilizer phosphorus sources. First point is make sure you soil test. Make sure you actually need phosphorus. And if you don't have access to soil tests, do some strip trials in the field. Do some strips with phosphorus fertilizer and some without, and you'll see if there's a difference or not. Rock phosphate is a source that's available in some areas, but most of the rock phosphates are very insoluble and very, very slowly available, and even then only in acidic soils. So if your soil pH is neutral or alkaline, the rock phosphate is just going to sit there. It's not going to dissolve. It's not going to be a good source of phosphorus to the crops. Livestock manure is often a very good source of phosphorus. We have issues where farmers have been using livestock manure on livestock farms as a nitrogen fertilizer, and they're actually putting on much more phosphorus than the crop needs, and it's built up in the soil and has become a pollution issue, so you have to watch out for that. Sewage sludge or sewage biosolids may be a good source if you've got it available and it's safe to use from a pathogen point of view, but some treatment plants are using alum or iron to flocculate the sludge, and that ties up the phosphorus so it's not in available form. So you may be adding phosphorus, but the excess aluminum in the alum could actually be tying up the phosphorus in the soil, and it's a net loss rather than a net gain. And the final thing is using the phosphorus in the soil more efficiently, making it more available to the crop. So we do that by rotating different crops, so the roots will explore different depths of soil and different soil volumes, improve the soil structure and the biological activity with cover crops, and livestock manure will help with that as well. There are some biological inoculants or additives that are promoted as being, improving nutrient cycling or improving phosphorus availability. I have found they generally are not effective. Some of the bacterial inoculants, only worked if the soil was quite deficient. If there was enough in the soil, the plant could get the phosphorus more easily directly from the soil. The mycorrhiza inoculants, there's generally enough mycorrhiza in your soil if you give the right environment that they can flourish. So I think you're not going to get a lot of benefit from most of those biological inoculants that are being promoted. Summarize, you can help the plants utilize what is in the soil more effectively, but you cannot extract what's not there. We cannot create something out of nothing. Biology can replace most or all of the nitrogen fertilizer, but not phosphorus. Phosphorus, we depend on what's in the soil or what we add. And it's critically important to test the soil so you know if you actually need to add fertilizer. And at one point I realized I didn't add into this as one of the things to do. If you check the pH of the soil, check the acidity, and you have an acid soil, there are times when the soil acidity is actually locking up phosphorus in the soil. Adding lime, raising the pH up closer to a neutral value can release phosphorus from that soil, make it more available to the plants. So you may not need to add the fertilizer if you can get to the same place with liming. But again, only if it is an acidic soil. That's the end of my presentation.
Nice. Now we start with questions. Tell me about the importance of soil science in agriculture.
Okay, soil tests are critical because we can't really tell by looking at the soil what the fertility is like. I like to think about productivity of the soil being a three-legged stool. So if you've got you need the physical properties, the biological and the chemical, and the nutrients fall on the chemical side. You have to have enough of the nutrients there. The nutrients that stay in the soil, that are held in the soil, we can't tell by looking at a handful of soil or a field whether there's enough there or not. And even looking at the crop can be misleading. We can have hidden hunger. The crop can be suffering from a lack of nutrients and not show any obvious deficiency signs. So taking a soil test is the only way to really tell, have you got enough nutrients there? Do you need to add nutrients? Or can you live with what's already in the soil and be productive?
What are fertilizer? How do they help the soil?
Yeah, fertilizers, we're really adding what is missing from the soil or what the soil doesn't have enough of. So if we're short of phosphorus, the crops won't produce enough seed, they won't produce the blooms, they won't have enough root growth, and so we overcome that deficiency, allow the crop to really grow to its full potential. And the thing is, if we've got not enough phosphorus and we add more nitrogen, well, you've wasted the money on the nitrogen because the crop cannot grow to its full potential. So again, it comes back to soil testing to know what are we short of, what are we adequate before we add other nutrients. We're most commonly adding nitrogen because for the grass crops, anything in the grass family. So that's grasses that we would grow for feed, but also cereal grains, maize or corn and rice. They're all in the grass family. They need a lot of nitrogen and they don't generate their own nitrogen. So it either has to come from the soil or we have to add it as fertilizer. So it's really important for those crops. If we're growing something like soybeans or one of the other grain legumes, they can fix their own nitrogen out of the air, so we don't have to add as much fertilizer. So it depends which crop you're using, which ones will need the most nutrients. But really, fertilizer, we're adding or we're supplementing what's already there. so we get maximum productivity out of the crop.
Okay. Is the use of fertilizer harmful for soil fertility?
It depends on the fertilizer. Phosphorus, potassium, a lot of the micronutrients, a lot of the secondary nutrients, they are held in the soil. And so as we add fertilizer, they will build up in the soil. As long as we're applying more than what the crop takes out, that will build up the store of nutrients in the soil and contribute long term to the fertility. For example, phosphorus, we usually say, okay, we apply phosphorus fertilizer, we might get 20% of it back in the year we apply it, but the other 80% stays in the soil. It's going to stay there and be available to crops, over the next 5 or 10 years. Nitrogen is different. Nitrogen moves around a lot more. It tends to convert into forms that can be lost either through leaching to groundwater or through denitrification and lost back to the atmosphere. And so nitrogen does not build up very well in the soil. So with nitrogen, we're looking at, okay, what do we apply each year that the crop needs and not anymore, because we're not going to get a benefit in the future.
Okay, sir. How can we improve soil fertility without fertilizer using?
Okay, so the first point goes back to soil testing. If you've got enough there, you don't need to add more. If you don't have enough there, or if you're really, really short, you're going to have to add something. We cannot, create something from nothing. With phosphorus, that's the one where commonly, soils will become deficient in phosphorus. We have to add something. Livestock manure is a good source of phosphorus. So if you've got livestock production in the area, you can get manure. It's going to provide both nitrogen and phosphorus to the crop, and will usually supply more phosphorus than the crop will need in a particular year. So that's one option. Depending how well the sewage treatment plants are operating, if you've got an urban area and they've got sewage treatment plants, sewage sludge can be a good source of phosphorus. The downside to that is some sewage sludge, they will use alum or iron chloride to flocculate, and that binds up the phosphorus and it's not available. You also want to be careful with it that you can have pathogens coming in the sewage sludge, so it's not always the best source. The other source would be, if there's rock phosphate available. I don't really like rock phosphate in most cases because it's so insoluble. It's slowly available. You can build up a soil eventually, but it's going to take a long time. And if you've got particularly an alkaline soil, it just doesn't dissolve. It really is only effective if you've got an acidic soil. Okay, so that's the phosphorus side. The other thing with phosphorus is if you've got some in the soil, you've got a stock of phosphorus there, but it's bound up. It's not in a readily available form. Getting more biological activity in the soil can help to dissolve that phosphorus, help to release that phosphorus that's in the soil. So growing cover crops, turning that in to build organic matter in the soil, help to build the soil life, so you've got more cycling of that phosphorus will help. Rotating different crops so that you've got crops that are exploring different parts of the soil will help to make that soil phosphorus more available. And keeping everything there, so you prevent soil erosion, you return the crop residues back to the soil. You try, you only take off, the part of the crop you're harvesting, and the rest of it gets turned back into the soil. Well, that will retain those nutrients there. And of course, if you've got good soil structure, the plant roots can explore more of the soil that's there. So that's a good way of, again, extracting more of what's in the soil out for you. So that's phosphorus. The same thing would go for potassium if you're short of potassium. Nitrogen, we've got actually more opportunities. Again, we have more places we can lose it, but we can use biology to put it back into the soil. The biggest way of doing that is symbiotic fixation. So growing a legume crop, especially some of the forage legumes, so alfalfa, clovers, in the tropical agriculture, there may be some other species I'm not familiar with, but something that you're growing to harvest for the green part of the crop, growing as a perennial, they will tend to fix a lot more nitrogen the crop will actually need and leave some in the soil. You could also grow some of the grain legumes, the beans or the peas, as cover crops, but you can't really depend on the residue if you grow them for harvest. Those grain legumes are very efficient at pulling all that nitrogen out of the root system that the plant fixes and taking it off the field in the grain. If you're going to use it as a cover crop, you need to take it really before it sets seed and turn it back into the soil while it's still green and growing vegetatively. And then as that breaks down, that'll release the nitrogen back to the crop. There's some work being done with, like say, non-symbiotic fixation, free living organisms in the soil that will fix nitrogen. They're not nearly as efficient. They haven't got the advantage of the carbon supply from the growing plant to feed the bacteria to fix the nitrogen. And fixing nitrogen takes energy. That's the thing. It's a trade-off. The plant gives some nitrogen or gives some energy to the bacteria, gets the nitrogen back in return. Free living bacteria would be the root exudates that are feeding the bacteria, but it's not as efficient as a nodule and a legume. The work I've seen, I think there's been some progress with rice and some of the free living bacteria in rice paddies. Nothing I've seen that I get excited about in dryland agriculture. Okay, so that's the first thing. The next part is, again, livestock manure, recycling the nitrogen back to the crop. The livestock extract some of the nutrients. A lot of it goes back out in the manure. We can put that on the field. The key with that is when you apply it, we make sure we work it incorporate it, because some of the nitrogen in the manure is going to be in the ammonium form. If we leave it on the surface, that's going to be lost to the air as ammonia gas. And if we lose it to the air as ammonia gas, the crops don't get the benefit from it.
Okay, message for our viewers.
Message, I guess to wrap up, soil testing is important. You need to know if you have to add something, but it's all equally important to know if you don't have to add something. We have opportunities or options for building soil fertility without adding fertilizer. But if you really don't have something in the soil, we cannot get something from nothing. So there are times we have to add something. And it's taking a balanced approach. And we talk about balanced fertility. So it's knowing if you've got a nutrient limitation, which nutrient it is, and focus on that, because we cannot replace one nutrient with another.
Okay, thank you for taking out your precious time and coming to our show.
It's been interesting. It's good to make me think about challenges in another part of the world, and I hope it's useful for your farmers. I hope it hasn't had too much of a North American slant that we do things a certain way here, and we know that isn't what works everywhere. But I hope you can take something from that is useful.
Thank you. Okay, bye.
Yep. Bye-bye.